Okay, so where we left off, we were doing case 2, which is when vectors are acting in opposite directions to each other. We had a 100 Newton vector going east, we had a 200 Newton vector going west, and I bet you can find the resultant without me even telling you the rule. Hopefully you're saying 100 west. What's the rule? Subtract and keep the direction of the larger. Okay, so subtract and keep the direction of the larger. Now you still need to line them up head to tail, so you still need to take one of these and put it on the head of the other. So you could move this 200 one over here, or maybe I'll move the 100 over because I have more room. So if I move the 100 one here so that it's on its tail is on the head of the other, so this is 100 newtons east, then the rule is the resultant starts where the first one started and ends where the last one ends. Okay, and so clearly it's 100 newtons. Look at the way it's pointing, it's west. Okay, these two vectors are 180 degrees apart. Okay, so for case 2, they're 180 degrees apart. I'm going to flip the page over so I have enough room to do case 3. All right, case 3 is when they're at right angles with each other. And of course, right angles means 90 degrees. So here's my box. And this time, let's say you're pushing with 40 newtons to the east. And somebody else is pushing this time with 30 newtons to the south. Okay, so remember our rules that you have to line them up so that they're head to tail. Right now they're not head to tail, the two tails are sitting here together. So you either need to take your 30 and slide it over so it's here, or if you want it, you could take your 40 and slide it down so it's here. Doesn't matter which one you do. Why? Because the resultant starts where the first one started and ends where the last one ended. So if you slid the 30 over, this would be your resultant. But if you slid the 40 down, and then it's these two, this would be your resultant. My red pen's having a rough day. Okay? The only thing that's going to make a difference, that's going to be difference between the two of them, is the angle. Remember, it's a vector. So this is the angle for if you slid the 40 down. And this is the angle if you slid the 30 over. All right, so I slide the 30 over. This is 30 newtons going south. We can find the resultant. It's a Pythagorean theorem. So it's going to be 40 newtons squared plus 30 newtons squared. And then you're going to take the square root. So it's going to be 50 newtons. But remember, force is a vector, so we need a direction. And the direction is going to be from this angle. So we have the opposite side and we have the adjacent side. So we can do tan theta is equal to 30 newtons over 40 newtons, which is 0.75. So then do inverse tan of 0.75, and you'll get theta is equal to 36.87 degrees. Okay, so now we can show our direction. And the way we show our direction with something like this is you draw a square bracket, and the angle in here is 36.87 degrees. And then we need to figure it out. You can't just say it's at 36.87 degrees. If I was standing here and you said turn 36.87 degrees, it'd be like, do I turn that way? Do I turn this way? So we have to say what we're turning off of. So we always start on some axis. So my purple theta here is starting from the east. And so we put east here. And we say then, so from the east, we turned 36.87 degrees south. We went down, that's south. So if you had moved your 30 Newton vector over, so it was head to tail with your 41, then the resultant would be 50 newtons east 36.87 degrees. Now, if you had moved your 41 down, you're still going to get 50 newtons here. The resultant is still going to be 50 newtons, but this time the angle is going to be tan theta. It will be equal to 40 over 30. Inverse tan of 1.3 repeating, theta is going to equal 53.13 degrees. So the answer to this one then will be 50 newtons, square bracket. Inside here will be 53.13 degrees, but this time we're not measuring off the east. This time we're measuring off, oh, I said north. Oh, I did put south there. Phew, I thought I put north. We're measuring off the south. So we put south here. And then which way did you turn? You turned 53.13 degrees east. This is also the right answer. Actually, these two answers are exactly the same thing, because look, they start at the same spot, they end at the same spot, they're pointing in the same way. It does not matter which way you write it, just you can move it either way, just make sure your directions match the angle that you found. Okay, so that's case 3. What do? Pythagorean theorem and tan to find the resultant. Now case 4 you're going to love. You're going to love it because case 1 was 0 degrees, case 2 was 180 degrees, case 3 was 90 degrees, and case 4 is any other angle between 0 and 180. Okay, because sometimes you might have a vector, 40 newtons east, and your second vector might be off. I'm going to start off by drawing them head to tail right away. Your second vector mightn't be at right angles, right? It might be something like this, and this would be 30 newtons. And maybe this angle is 30 degrees, let's say, down here. Okay, we can still draw our resultant in. Starts where the first one started. Ends where the last one ended. And this would be like you had a box and someone was pulling it this way and someone was pulling with a second string up at an angle, right? So in the end, the resultant force will look like this. So we can't use Pythagorean theorem. They're not right angle triangles. But what we can do is we can realize that this 30 newtons is really just the hypotenuse of a right angle triangle. So we can draw in the legs. This would be the x component, or the x leg, and this would be the y. And actually every vector in the universe is really a hypotenuse looking for its legs. Well, lucky for us, we can find them because we have the hypotenuse and the angle. We can find the legs. So to find x, it's the adjacent side. It will be cos of 30 is equal to x over 30 newtons. So x will equal 30 newtons cos of 30. 0.866 times 30 is 25.98 maybe newtons, and it's going to be east. And we can find our y. It's the opposite side, so it'll be sine. So sine of 30 is equal to x over 30 newtons. X is equal to 30 newtons sine of 30. So x is equal to 15 newtons. Okay, so, whoops, I just switched x and y. This is y, sorry. The adjacent side was x, y. They're both not x. Okay, so this side is 15 newtons. This side is 25.98 newtons. How does this help you? Because once you find the hypotenuse is searching for its legs. It would give anything to find its legs. Once you found its legs, it's like the hypotenuse no longer exists. Now you have a right angle triangle whose bottom is 65.98, whose side is